Got it. So that would be our answer for number 3. Okay, next question. We have integral of cosine inverse x minus dx. Okay, well, while this might seem a little bit complicated too, I mean, like, it's not complicated, but you might not know how to start this one. So we're just going to do the same thing. We only have, like, technically one function. We also have one here. We have inverse. So we're just going to do u equals cosine inverse x, and then du is going to be -1, and then root 1 minus x squared. So this is the inverse cosine derivative formula that you should all be familiar with if you're calc students. And then dv, we're going to set it as 1 times dx, and then v is just x. Right? We've done this before. So this would be our, like, form before we actually start. So equals uv x times cosine inverse x, and then minus v du, so -x over root 1x dx. We're going to take the negative out, so we're going to combine this with the negative in front, so that's going to be positive. X cosine negative plus 1 dx. So in this form, actually, we can use substitution. Pretty simple, right? So we can do u sub again of, okay, maybe you should do a different variable. I'm going to choose it to be like a z. Z equals x. Oh, never mind. Z equals 1 minus x to the second power. dz equals -2x dx. Yeah, this is a little confusing because I'm not used to z's. And then x dx would essentially equal -1/2, and then dz. Alright, okay. So, considering this part only, we're just going to move away from the whole equation. We're just going to integrate this one only first. Okay. So, -1/2 comes out of the integral. And then since this part is being substituted, we're just going to leave it like that. And then z is 1 minus x squared. So we can see that z to the power of -1/2, would be the substitution for 1 over root 1 minus x squared. And then we also have dz from here. Okay, so this is pretty simple. -1/2 plus 1 would be 1/2, and our reciprocal of that would be just 2, right? So negative 2 times 1/2 is just 1, and then z to the power of 1/2. Yep, that's how you do it. Plus z, I guess. Okay, so we're going to substitute this back in. So negative z, or negative times 1 minus x squared to the power of 1/2 plus c would be our integral from the second part. So combining with the first part, we're going to get the answer of x cosine inverse x, and then minus plus c. So this would be our answer for number 4. Alright, moving on, we also have t to the power of 5 sine 3t to the third dt. So for this one, it also seems a little bit unconventional in a way. We're just gonna simplify this into t to the third times t to the second, and then sine 3t third dt. So for this one, we can do kind of a u substitution first. If you see, we're going to do u, or let's not do u. let's do z again, because we're going to do integral by parts later. Z equals t 3t third dz equals 9t second dt. So we see a similarity here. So to leave t squared dt, we're going to divide each side by 9, which means 1 over 9 dz equals t squared dt. So that's that. And then we're going to plug this back in. So instead of these two, we're going to do these two. So 1/9 comes out to the front, outside. And then we have a dz instead of t squared dt inside. And then we're going to plug in sine, and then sine z, because 3t to the third. And then t to the third, we can simplify that as z over 3 equals t to the third, right? So we're putting everything in terms of z. So z over 3 times sine z, and then we also have dz at the end. And then we're just going to pull out the 3 outside. So it's going to be 1 over 27 times z sine z dz. Okay? And then we see that we have an integral by parts form right here. So u equals, well, z. Because according to this, algebra A comes before trig. So we're going to use this as our u. Du equals dz. dv equals sine z dz. v equals negative cosine z, right? Okay, and then times u times v is negative z cosine z, and then minus would just be plus v times du, which is cosine z dz, right? Okay, so 1 over 27 times negative z cosine z, and then the integral of cosine z would just be sine z, right? Okay, and then plus 3. But then one thing we should do before we go would be to substitute in z, right? So z is just 3t third. So going back, we're going to do 1 over 20. Wait, let's just leave the 27 outside. It's a little bit complicated. 3t third cosine 3t third plus sine 3t third plus c. So this would be our answer for number 5. Okay, thank you. Alright, so we're back with integral by parts practice part 2. So we're going to start with number 6, which is integral of e to the 2x times sine x 3x dx. So this one is similar to number 2 because we're dealing with exponential and trig again. So I think it's basically going to be pretty similar. We're going to start with the formula LIATE. Okay, and then we see that trig is above exponential, so we're going to put u equals sine 3x, right? And then du is going to be cosine 3x times 3, which is like chain rule, and then dx at the end. And then dv would instead be e to the 2x, right? So integral of e to the 2x would actually be 1/2 times e to the 2x, right? So that's that. And then now starting off with the formula, u times v is 1/2 sine 3x. Let's just say e to 2x over 2 times sine 3x. And then minus v du. So we're going to get the constants out of the way. So put it outside the integral. So 3 over 2 would be outside. And then we have e to the 2x cosine 3x. Alright, so we can kind of see that the format is still pretty similar to the original one. like the sine x is changed to cosine x, but I mean like the complexity is pretty similar in general. So we're going to take it one more time, the integral of this one more time, to see where it leads. I mean, from the past example, I think you guys probably know where this is going to lead towards, but yeah, let's just do it. And then number 2, the integral one more time, so we're going to put u equals cosine 3x, right? Du equals negative sine 3x, but then 3 outside, dx. dv equals e to the 2x, v equals 1/2 e to the 2x, right? Okay. U times v is going to be 1, okay, minus 1/2, okay, 1/2 and then negative 3, right? So it's going to be positive 3 over 2 outside of integral, and then e to the 2x sine 3x dx. Okay, and then like I said before, this itself is a function, so it's y equals. So in each of these steps, on the other side of the equal sign, there were always the y's here. We just, I guess, didn't include it for simplification process. And then, so y equals this one. So since there's technically a y here, we can say that this one is e to the 2x sine 3x dx, right? And then since we have some like terms here, we can try to combine it to the other side. So that would be e to 2x over 2 sine 3x minus, okay, well, this is a little bit complicated. And then minus 9 over 4 e 2x sine 3x dx. Okay, we're going to combine it with this one. So combine the like terms, 9 over 4 plus, I guess, 4 over 4, which is 1, would be 13 over 4, right? So let's put it here. 13 over 4, right? And then e to the 2x sine 3x dx equals e to the 2x over 2 sine 3x minus 3e 2x cosine 3x over 4. Okay, and then to find the actual answer, we're going to divide each side by 13 over 4, so e to the 2x sine 3x dx equals, I'm just going to say the same thing. Same thing right here. Okay, and then I'm just going to put a huge square bracket and use a shortcut like this. So this is going to be our answer. Alright, and then going off to number 7, this is our last question. It's a word problem. The rate of change of dust accumulating inside a cylinder in milligrams per second is given by the function g of t equals ln t over t to the 5th, where t is measured in seconds again. So find the change in the amount of dust collected in the cylinder in the first 10 seconds. So first 10 seconds, that's interesting. So it says the change in the amount of dust. So that means we need to take the integral of g of t. So in amount of dust equals 0 to 10, right? So first 10 seconds, 0 to 10. That's our limits. And then g of t dt, which means 0, 10, ln t, t fifth dt. So we can simplify this into 0, 10, and then t to the negative 5th times ln t. And then for this one, we have LIATE, right? And then honestly, t to the negative fifth can count as algebraic. So that's A, and then ln is, well, log, so L. So L would be our lovely u, and then dv would be t to the negative fifth. Let's see how this goes. du equals 1 over t dt, and then v equals negative 1/4, right? T to the negative 4. Okay, so we have negative 1/4 t. Okay. Now that we have this, we can try to solve this out. I'm gonna disregard the definite integrals right here for now, and then u times v is negative ln t over 4t, oh, t to the 4th, yeah, and then, oh, minus is not actually minus because we have negative 1/4, so plus, and then 1/4 comes out, and t to the 4th times t1 dt. So we have negative ln t 4t plus 1/4 times t to the negative 5th power again. Alright, and then that's that. And then let's try to take the integral of this. Well, we know the integral of this would be also negative 1/4 t to the negative 4. Yeah, and then for this one, the important part is that we have a definite integral. So it's gonna be, you have to do this one, also definite integral, and then this in general, also definite integral. So, well, since we're taking the integral by parts, and then this is also the result of the integral by parts, we have to apply the definite integral in the first part as well as the second part with the actual integral sign. So after computing, I think you guys should just plug this into your calculators, and whatever answer you get would probably be the right one, because this one is pretty self-explanatory, so I'm not going to walk through the calculations. Okay, and then so whatever the answer you get for this one would be the answer. And then it says find the average rate of change of the dust accumulating inside a cylinder for the first 5 seconds. And then before we move on to part B, one thing I want to clarify for part A is that if it said find the amount of dust collected in the cylinder by like t equals 10, then you would have to take into account the original amount of dust in the cylinder before you start the timer. So you would have to add a certain value to this because the integral just represents the change in the amount from t equals 0 to 10. And then because that was what the question was originally asking, this was it. Like, this was the only thing we needed to do. But then if it asked for the actual amount of dust, then you have to add the original amount plus the change so that you can actually get the amount of dust collected. Okay, just a little clarification. Okay, and then now we're going to move on to part B. It says average rate of change. So average rate of change, you might be thinking like, oh, it's something like it's instantaneous rate of change versus average rate of change. So instantaneous is like derivatives, and then average is like average rate of change is the opposite of that. You could think of it that way, but then one way that we can do this using integrals is to do the average like value formula. So average value formula is given by 1 over b minus a, b, and then the certain function like f of t dt, right? And then right here, what we're given, the function we're given is g of t, which represents the rate of change, right? So to get the average rate of change is our value, right? Like that's the same thing here. So 1 over b minus a b, and then f of t would just be g of t, the rate of change. So instead of like at rate of change here can be substituted in for the value. So since we're finding the average rate of change and we're given the rate of change function, we can use this average value formula to get the average rate of change of dust. If you want to do like g 5 minus g0, 5 minus 0, this one also works because this is the I guess the known way to find the average rate of change. But then this one, average value, this one also gives the same answer. So whatever way you want to do, you can choose. But for today, we're going to use this one because we're trying to practice integrals. So here, we're going to do in the first 5 seconds. So 1 minus b minus a, so 5. And then 0 to 5, ln t, t to the 5th, and then we already got the derivative, integral by parts derivative from part A. So, just plug in 0 and then 5, and then divide that by 5 to get the average rate of change of dust. Yeah. All these questions you can use graphing calculators for, so definitely use those, and then I'm not going to walk through the graphing calculator portion.